And so when we looked at calcium and ATP, you might expect there to be some decrease in ATP, but in fact, there's an increase. Some of that is almost certainly due to the calcium stimulating the mitochondria, and that helps the ATP go up. But it's surprising that it's kind of overcompensated. It goes up rather than staying constant. And it goes up substantially. And the story seemed fairly straightforward. Calcium release stimulates ATP production from mitochondria at the same time as consumption goes up. But more recently, we found that there's more to it than that, because with PLC zeta, you get the same effect, but it's actually quite modest. The increase in ATP is quite modest with PLC zeta. At fertilization, the increase in ATP is larger, and that's partly because it's twofold. And there's a late kick of ATP that comes in after about an hour, which is not explained by PLC zeta. And in fact, if we suppress oscillations, we still get that second kick of ATP. So one of the things we're interested in now is the sperm may not only introduce PLC zeta, but something else which stimulates mitochondrial ATP production, which is, I didn't really expect that. And that's kind of an odd thing to think about, is that there's another sperm factor possibly that stimulates mitochondria, and that allows the ATP to go up at fertilization. It may be involved in the initial changes as well. So that something else is stimulating mitochondria and not just calcium.